Madison, get your homework out.
And you did yesterday. Yeah, you'll get that in student advisement. Guaranteed. It's so hot.
I've heard that before.
No, and usually I do it maybe once or twice. Because usually if I tell you I'm going to turn it into student advisement, I will. If I don't tell you that, I just didn't do it.
All right, here we go. Voice is off. Homework is out. I said it 2 times now. Any questions on the homework?
I don't know.
Was this the right thing or the wrong thing?
What were you doing? I need a pencil.
No, this is the right thing. All right.
Wait, that's not what's on the board.
Okay. Do I need to go Miss Boyd on you?
Miss
No.
My willingness to cut you some slack is about at this level right here, which is almost nothing. Right? Get your stuff out. Quiet, please.
On the whiteboard.
1 through 10 also. I don't know why that says 1 through 12.
Yeah, it's 344.
Okay, wrong too. 344 to 345. I don't know why that's messed up. Oh, this is home. Thank you. Connor, or sorry, John figured it out.
Found it.
There we go. Sorry.
Wait, no,
Well, I found the homework.
Yeah.
At least.
Can you stop?
Yes.
Okay, there's not a third chance for this class. Yes, right.
She didn't remember it, and I typed the wrong page.
Hey, remember, you can always go on Teams. You can always go on Teams. It will always be listed on. The only issue is that if it's on Teams and it's not a worksheet, then I don't post it until about 8 o'clock at night. But you can always find your homework. Go on Teams, at least after 8 o'clock. If it's a worksheet that it's posted that day, so that way the online learners can do it that day. But if it's a non-worksheet like last night, then it will show up at 8 o'clock. And then take your friends better, baby. All right. Here we go. Any questions? All right, grade your papers. Number 1. Now we're doing volume, so everything's cubic, right? Number 1 is 24 cubic centimeters. Number 2, 98 cubic meters. Number 3, 180 cubic millimeters. Number 4 is 4 cubic meters. Number 5 is 72 cubic centimeters. Number 6, 70 cubic meters. Had a bunch of people come up to me, ask me how to do number 7, and I said, well, I gave you one side of a rectangular prism. Well, if they only gave you one side, that meant that rectangular prism is actually a cube, right? So number 7 is 1. You had to multiply 1.1 3 times. 1.1 times 1.1 times 1.1 is 1.331 cubic centimeters. Number 8 is also a cube, 9.261 cubic meters. Number 9 is your classic rectangular prism. That is 9 cubic meters. And the last one, number 10, is 187.5 cubic centimeters. All right, that was it. Pass those to the left, to the left, to the left. Pass those to the left, and then copy down your homework for tonight. No spheres.
Why no
All right, hearing a bunch of chit chat. Knock it off. Copy down your homework. Get your stuff on, please. All right, so yesterday we had our first 3D shape, the prism, came in two flavors, rectangular, triangular, and we got two formulas. Today, an easier day, we only have one formula because we're only doing one shape today. What's up, Louise? That's for Laura. Say again, Louise?
I already gave it away.
Okay, you got an extra one?
Yeah.
Okay.
Oh, right.
All right, so what is that formula for today? Oh, he just passed too many back. There we go. What is that formula for today? I say, what is the shape? Sorry. Cylinders. That's what we're doing today. All right, so volume of cylinders. This one will be slightly more complicated than the other two. For the last class, we've been dealing with volume. What I said for volume was you take a three-dimensional shape and you fill it full of tiny cubes, and then you count the cubes. In area, we fill the flat surface full of squares, and we count the number of squares. For volume, we fill the shape full of cubes, and we count the cubes. Now, obviously, that is a very cumbersome process to literally fill a shape full of cubes. So we come up with formulas to make our lives a whole lot easier. So now we have two formulas, one for rectangular prism, one for triangular prism. Okay? Today we get a third one, and it's for our shape, the cylinder. Okay, we express anytime we do volume in cubic units, so to the third power. Why? Because remember, if you have a cube, that's length times width times height, and all the sides are the same, so you would have 3 centimeters that you're multiplying together. Okay? Area, that's why it's to the second power, because it's a square, 2 that are exactly the same. All right, last class we did these two shapes, we got our two formulas. I do want to point out for both prisms, rectangle, for any prism for that matter, that the actual formula that's in the book is capital B times H, where B stands for the base area times the height. B stands for the base area times the height. Okay. Base area is, well, if you think of that shape at the bottom of it, whatever that shape is, and you stack those one upon the other, that would be the height of it. That's how we get to the volume. Okay. Base area times height. Today, we will not be doing a rectangular prism. By the way, the formula was length times width times height for that. We will not be doing a triangular prism. Area of a triangle is 1/2 base times height. Times the height of the prism. We got 2 heights, which is why we have a complicated looking formula. It's still pretty easy to use. The complicated looking formula has these words attached to it. Triangle, triangle, prism. Okay. To find the base and the height of the triangle, you look for the little tiny square. We did that yesterday. It's still 3 numbers multiplied together divided by 2. Today we get to a slightly more complicated formula, because today we're going to be dealing with the cylinder. So box number 1, let's draw one. How do you draw a cylinder? Well, here's how you draw it. Grab your pencils. Step number 1, don't draw a circle, draw an oval. Step number 1, don't draw a circle, draw an oval. There's my oval. Step number 2, underneath of it, or above it, doesn't make a difference, draw another oval, but this time, make the top part of your oval dashed. That's the part we would not see. Connect the sides, and you made your cylinder. Not a very good one if you're as bad as an artist as I am, but that's how you make a cylinder. Okay, we all right? That's all we're putting in box 1 is a drawing of a cylinder. Clearly, a cylinder is made up of. It's made up of 2 circles and a curved side. Okay? We won't have names, at least this year. Next year we will, for the side, but we do have names for the top and the bottom. We're going to call the top and the bottom. We're going to call them the base. Okay? So the top and bottom of a cylinder are called the base. The side, well, I'll go ahead and tell you. Next year it's called the lateral surface. But next year is when we will calculate that, not this year. All right. Going back, box 2, we're going to write the formula. Watch me do it first. Going back to our formula for prisms, the actual form for any prism is capital BH, where B stands for the base area times the height. it turns out it's the same thing for cylinders. If you think about this, you guys are not that young. You remember CDs?
Oh,
You
yeah.
remember when you bought CDs, they came in
Yes.
this, a cylinder of CDs. That's because the CDs were stacked upon one the other, right? So as they're stacked one upon the other, it forms that cylinder.
I have that in my car.
So what's the base of a cylinder?
Circle.
So it's a circle multiplied by how many circles you have stacked upon each other. That's the height. So in other words, rectangular, triangle, or any prism is base time or base area times height, so is a cylinder. The only difference is that the capital letter B is not a rectangle, it's not a triangle, it's a
Circle.
circle. What's the area of a circle?
In pi or
We just had it on Friday. It's
pi or square.
pi r squared. So it's literally pi r squared
Times it.
times the h. There you go. There's the formula.
Wait,
Oh, I need an h. There we go.
Wait, for all prisms? Wait,
For all prisms and cylinders, technically,
it's just
it's
the area of the base
times the height.
Okay, well that's kind of easy.
That is easy. And that's why on all tests, whenever someone hands you a resource card, that's what it gives you. Now, if you've forgotten what capital B stands for, then you're in trouble. But if you remember that B stands for base area, then that is sufficient. But for most of us, we would much rather remember that V for volume of a cylinder is equal to pi r squared h. Because we're going to forget what the capital letter B stands for. By the way, CD stands for?
That would be
Absolutely not.
something would be data. The D would be data.
When
I've heard of
these things first came out, they were the size of a pizza. They were this big. Literally. They were called laser discs. And a laser disc was literally the size of a pizza. They're called CDs because the C stands for, not circular, it stands for compact.
Oh yeah,
Because
yeah.
it ain't the size of a pizza anymore, it's that size. So it's much smaller. That's why they're called compact discs. Because they're not a pizza anymore. Okay?
They're probably gonna want
All right.
something to
DVD stands for?
digital viewing device.
No.
That one?
Digital video disc.
Disc. All right. By the way, a CD and a DVD are basically the same technology.
Yeah,
One
except TV can store more data.
store more data, right? Uses a different color laser.
How does it work? Like a whole movie goes
Do
into one.
you want me to waste time and give you that
No.
explanation?
Yes.
So if you can imagine the surface of your compact disc, it's actually made of aluminum, right? And the aluminum, if you took you can see it with a microscope. If you take a microscope and you look at the surface of a CD or a DVD, what you find I'm going to give you the flat version. So I'm not looking down on it, I'm looking sideways. So this is the disc, I'm going to look sideways on it. What happens is you get little tiny pits, okay? You get little tiny pits. And what happens is the laser actually doesn't move, it's the disc that moves. It goes around, and then the laser goes from, I forget if it's outside to in or inside to out. And what it does is it shines a light down. And what it can tell is, based upon how long it takes light to go into the pit and out of the pit, it's either riding on top or it's inside of a pit, okay? And so as the laser shines down, it comes to flat surface, I'm in a pit for a certain amount of time. And then I'm out of it, and then I'm into the pit. And then I'm out of it, and then I'm into the pit. And what happens is, if you're inside of the pit, I don't know, I'm not an engineer. I don't know if it's a 0 or a 1, but it's one of the two. You're either a 0 if you're outside, or you're a 1 if you're inside. It could have that backwards, I just don't know.
No, yeah, that's right.
Binary.
So it's binary code,
And is
just
that-
like this clock.
and is
And
that
what happens is they take music, and they break it, and they turn it into a bunch of numbers. Like, how does that work?
How
Well,
did it take
you think about sound waves, which is a wave. All they do is they convert this to a number. And this number here might be 8, and double that would, of course, would be 16. And down here would be a 0, right? And so they take each one of these numbers of the wave, the sound wave. We're breaking this up into really, 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 really tiny bits of time. This is time as it goes on. And then they say, well, this time is the sound is making a 0. Here it's making an 8, and that's how it converts it into sound waves.
So wait, the laser of a DVD player shines on the disc, which
And it's either going to be a 0 or a 1.
and
And then that
they put-
represents a string of these zeros and ones, represents one bit of time of a sound wave.
So they basically take the code of everything they filmed or audio and stuff, and they turn it into binary and they put it in there.
Pictures work the same way. A picture is either, it's made of light, so the light is either dark or it's not dark,
Yo, that's
right?
deep.
And anywhere in between. We're going to get way off track here. But,
And by the way,
that's literally how it works.
the laser goes from inside. The laser goes from inside.
Yeah, that's
Yeah.
true.
And on records, it goes the opposite. It goes from outside in.
Yes.
Mr.
All right, yes.
How does it make the color then?
So it turns out that when you see light, light is on a bandwidth. On this end over here, you've got your reds, and on this end over here, you've got your blues, and anywhere in between. Well, you can assign numbers to that, right? So if you're way over here on the red scale, right, you might be I'm making these numbers up, you might be the number 1. And if you're way over here on the blue scale, you're number 10. And anywhere in between, you've got your other numbers. You know, Roy G. Biv,
Red, orange, yellow, green, blue.
red, or this is by spectrum, by the bandwidth, like literally whether it's a short band or a long band. Red is long, blue is short. So it goes red, Roy, orange, yellow, Roy, G, green, blue, indigo, violet. And those are all the colors that we see with our
I
eyeballs.
can't tell if you're a mathematician or a scientist right now.
Well, this is all math.
Mr.
So now we're gonna do cylinders. Okay.
No, it's a different color.
So here we go. If we want to talk about it when we finish the lesson, we can. All right, back up here. Well, technically that is the formula for both prisms and for cylinders, capital BH. But we would much rather use pi r squared h. Step number 1, what's the shape of the cylinder? Step number 2, write the formula, pi r squared h. Step number 3, plug in the numbers. Hey, how many numbers, Maddie, do I need to plug into the formula?
Me? Or the other?
You.
Okay, go through math. I don't.
How many numbers do I need to plug in?
A lot.
Well, what is a lot? 2. So all I need is the radius and the height. What's the radius and the height?
Radius is 2 feet.
So those are the numbers that I plug in. That's what you'll type into your calculator. Now, let's talk about things in terms of pi. Remember that conversation a while ago? If we want to put our answer in terms of pi, we don't multiply by pi, we leave pi as pi. So we just do the rest of that. 2 squared is, 4 times 10 is, not 8, it's 40. So in terms of pi, the answer is 40 pi with the units, feet cubed. If we want to not put it in terms of pi, that means multiply by pi, then we take 40 and either press times the pi key or 3.14, and we get that number. Now I'm going to be doing a lot of rounding today. Remember, whether you use the pi key, you're going to get a slightly bigger number. If you use 3.14, I use 3.14 for all my answers, you're going to get that number. Who's lost? This is for all of them where we are given the radius and the height. It's not for all of them for all the problems for homework, and we'll get to all the possibilities as the lesson progresses. But yes, 40 pi, if you're asked to leave the answer in terms of pi. If you're not, then it's 40 times pi, which in this case is 120, about approximately, because remember we're rounding, 126 cubic feet. All right, box number 3, here we go. Box number 3, here we go. Box number 3, here we go. All right. Step number 1, what's the shape? Cylinder. Step number 2, write the formula, pi r squared h. Right, pi r squared h. Box 3. Pi r squared h. Step 3, plug in the numbers. Maddie said all we need is the radius and the height. Can you screw this up? Yes. You can't screw up a rectangular prism. It's 3 numbers multiplied together. Even if you mess up length, width, and height, you still get the same answer. This one, if you mess up the numbers, it screws everything up. You have to put the radius for the radius and the height for the height. If you say 12 is the radius, you're going to get to an answer and it will be wrong. Okay? 10 is the radius. So 10 goes for R, H is 12. Who's lost on that concept? Because 12 squared is way bigger than 10 squared. 10 squared is 100. So that's 100 times 12. That's just 12 with 2 zeros. So in terms of pi, the answer would be 1200 pi. However, If you want to know the actual answer, then you take your calculator, you multiply 1200 times pi. Do it. 1200 times pi.
A big number.
Well, remember to round. It's not a big number. It just has a lot of digits.
Yeah.
But it's actually not a big number. It is,
3,600.
okay, depending upon how you round it, we get somewhere around, I got 3,728. All he was doing was saying, well, pi is close to 3, so it's somewhere around 3,600. Right. Depending upon whether you use pi or 3.14 depends upon your answer. It's not, because pi is a larger number.
And it's just a bunch of digits. Even a calculator can't store as
Correct.
much digits as pi.
Pi, the digits never end.
Really?
Okay? That's why it's called an irrational number.
Is it the definition of infinity?
It's a definition of irrational number, yes.
What's irrational?
Irrational, not rational. Rational means a number that can be written as a fraction, a ratio. Irrational are numbers that cannot be written. You can't write pi as a fraction. Okay? Yeah, so if it doesn't have any units, you put units cubed. Okay? All right, box number 4, here we go. Nathan, are you paying attention? What's the radius here? You guys agree or disagree? Laura's the only one that's going to disagree.
I disagree.
Caitlin disagrees.
It's actually.
We're getting a chop your head off thumbs no here.
What?
You know, ancient Roman emperors. You know what this meant? So Rome is famous for lots of things. One thing it's famous for is the gladiators, right? Right? And at the end of a gladiator fight, literally, that doesn't mean someone killed someone. That meant someone was subdued. They couldn't fight anymore, right? You either died or you couldn't fight anymore. You were still alive. So you stood in front of the emperor, and the emperor either did this or they did this. Well, this literally meant.
What did this mean?
That means that they live.
That's fun.
All right. All right. Yeah, it's a fun game unless you're playing it, right?
Yeah, it's all funny games.
There we go.
Does that mean you get to keep fighting or you're released?
The winner obviously is always the winner. The thumbs up, thumbs down was for the loser.
I know, but if you get the thumbs up, does that mean?
That means the emperor spared your life.
Okay, so you still have to keep fighting.
No, the fight was over. You lost the fight. It just meant that you didn't lose your life.
Well, could you go to the fight?
I don't know that much. Ask Mr. Callinell. He can tell you.
Yeah.
My historical knowledge for that literally is related to just a few things that I've read and a movie or two. And who knows? It's Hollywood. They can always get that wrong. Okay. So we all gave Nathan the thumbs down. 16 is not the radius. What's the radius, Nathan? 8. It is 8. So it is the one thing that I can mess with you is I can give you the diameter instead of the radius. Be careful. So the radius here is 8. Step 2 or step 3, we plug in the numbers. Okay. If you have a calculator and you're not putting it in terms of pi, you can literally type this in your calculator unless you have the dollar calculator. Who's the kid with the dollar calculator? Was that you, Connor? Right. Connor must do 8 squared first. He doesn't have a square button on his calculator. So he has to do 8 times 8 times 40 times 3.14. If you have a better calculator, you can literally do 3.14.
So I have to do 8 times 8 times 40 times 8.
You got it.
Well, it's not that bad.
It's not that bad, correct. It will only get bad as if you have a dollar calculator and you're into higher level math.
Wait, I can't just do 8 times 8 times 40?
That's what you just said to do.
I know, but can I put it all in one?
You can do that, yeah. You can do
Because
8 times 8 times, yeah.
So I can do plus and minus on the same line, but I can't.
Yeah, don't do any plus. If all you're doing is multiplying, you can put it all together. But if
So-
there's any adding or subtracting with multiplying, don't do that.
So I can do adding and subtracting together in however order I want to, and multiplying and dividing in whatever order I want to, but whenever they're mixed up.
Well, no, because you got to go left to right for multiplying, dividing, and adding, subtracting.
Well, so if I were to put like 8 plus 9.
Subtraction and division subtraction and addition combined together gets you into problems. Multiplying and dividing together gets you into problems. Notice all we're doing is multiplying really here. 2 8s multiplied together are 40 and a pi. So you can actually enter those in any order. The issue is that when you have addition and subtraction put together, you can get the wrong answers. All right. Long story short, in terms of pi, it's that big honking number. Not in terms of pi, it's that number.
Yeah, there we go.
Just be ready. There's a couple tonight for homework. They say leave the answer in terms of pi. So that would be 2,560 times pi cubic centimeters in terms of pi.
And so if they said leave it in terms of pi, all we would just do is 8 times 8 times 40 and then put pi at the end of the answer.
And units. And units. Cubed. Yes.
How did you get 8?
How did I get 8? Does this go halfway or all the way across?
Oh.
That's why it's 8. Soraya? Okay. We okay, everybody? All right. Do box 5, please. Danny, what's the radius? Couldn't fool Danny. Tried. Height here is 25. You got this, Manny? Madison, you got this?
Oh, yeah.
Jake, you got this?
Yes, sir.
Pretty easy, right? I agree. Cylinders are easy.
25.
5 squared is 25, so this is really 25 times 25. That's a good one to have memorized too.
It's just a lot.
25 times 25?
625.
625. That's a good one to have memorized. In terms of pi, or what the instructions say, so this one, we're not multiplying by pi.
Good.
A lot of times, if you're not reading carefully, you can just go right over it. And even though you know what you're doing, you get the wrong answer because you didn't read the instructions. So this one said leave in terms of pi. So 625 with a pi and then the units, and we're done. David, yes, no? Okay.
Yes, no, maybe so.
Yeah, the maybe so thing is probably where we want to be on sometimes. On this stuff, though, this is a yes or no here. If it's a really complicated thing, then it's a maybe so. All right, all by yourself, do box 6. None of these are leave in terms of pi. I want the approximate answers. Okay, do box 6, please. Everybody okay to do this by yourself?
I guess.
Okay.
Half of 6. Oh, it's 3.
Half of 6 is 4.
If I get a decimal, do I need
I'm trying to mess with
it?
She rolled her eyes, so she understood.
What do I do if I get a decimal? 3 times 3 is 9.
You can get a decimal, absolutely. So let's round to the nearest whole number.
What if it doesn't do 3? That's 6.
So, like, in what case what would they have to give you? Oh, you're looking ahead. We'll get to that here in a second. Next year, for this problem, they might not give you the radius, they might give you the circumference.
22.
And from that, you'd have to calculate the volume. But not this year.
This is easy.
I agree. All right, Aiden, first one, the blue one. What do you got? Final answer.
Me?
Yeah.
Um, 8,042.4.
Nowhere even remotely close. You know, want to know why you got it wrong? What's the radius?
Oh, I did the wrong one.
Yes, you did.
You're mean. You're letting children fail.
You hasn't failed yet.
Not yet. I'm failing this class.
And I will always let you fail. That's a choice you make.
I don't choose to fail.
I don't want you to
Accidentally
fail.
You want me to fail?
If I wouldn't let you fail, then I would give everyone an A and we wouldn't even teach anything.
Yay!
Letting you fail is allowing the possibility of failure, but providing you with the opportunity and the decision of whether or not you want to study and prepare.
Give him a fail. Oh, I have a question.
But will I let you fail? Absolutely, I'll let you fail.
Oh, no, you keep us here.
I don't want you to fail, and I'll be here for you to keep you from failing.
I got an
But you have that.
My grading club at all.
We've already had this
I
discussion.
know, but like it shouldn't have like gone up a little bit.
Depends what it was before the test.
We'll see.
That's what I'm saying. It depends what the impact that anything, whether it's homework, whether it's a quiz, whether a test, has upon your grade depends upon one thing, and that is what was your grade before that event.
But you figured it would at least go up like a tiny bit.
If your grade was already your average for your test a 79, and you get a 79 on your test, it will have no impact on your grade.
I got an A on my test.
Okay.
I don't know what I got, but I got a 38.
Okay. Plus the fact is, there's also a lag time between when I hand the test out and when it's in your grade book. So for instance, if there was 4 days that went by between when I put it in the grade book and you got it back, then you've already seen the impact of that on your grade. All right, Aiden, do we have an answer yet?
Yeah.
What?
282.7.
That's what I got. I rounded to 283. Okay. All right. Danny, you got the red one? What do you got? What's the radius? Hold on.
Oh, sorry, come on. And then do it like squared.
Well, what's 1 squared? That one's pretty easy. 1 times 22? So it's just 22 times pi, whatever that is. You have a calculator for the snake, you'd be dead.
69.
No way.
It's 69.08.
69 what though?
69 meters.
There we go. Now I'll buy that. I wasn't going to buy 69, but yeah. 69 cubic meters. Very good.
I didn't do any calculations.
Yeah, but 3 times 22 is 69, but it's going to have some decimals, but they're small, so they just round to 69. All right. So Danny was looking at her forwarder. She was looking at homework, and she was noticing that sometimes we don't solve for volume, we solve for other things. So here's where you need to start paying attention. What if, instead of solving for volume, I tell you the volume? Hey, the volume is 96 cubic centimeters. The radius is 4 centimeters. What haven't I told you?
The height.
I haven't told you the height. So this is one where you're not solving for the volume, you're solving for the height. Hey, it's still the same 4 steps. What's the shape?
Cylinder.
Step 2, what's the formula for volume of a cylinder? Okay, so it's still the same 2 steps. The 3rd step is the same. Plug in what you know. This time I know the volume, Jake. Where would I write that?
You would write that.
What letter would that replace?
That would V.
The V. So the V is 96, while the R is 4. So in other words, what I don't know is the H. That's what we're going to solve for. Watch me. Watch me. Yes. What's 4 squared? 16. What's attached to H? How is it attached? How do you get rid of multiplication? How is pi attached to H? How do you get rid of multiplication? So we need to do 2 divisions, 1 by and 1 by pi. Some people can do that all in one step, and that's fine. I divide both sides by pi on the right side, the pi's cancel. Somebody calculator, do that real quick. Okay. So about 30.6. How do we get rid of the 16? So divide both sides by 16 and you get to what H is. It's going to be what? 2, 1? That would round about 2, right? And what are the units going to be? Is it going to be cubic? Were we solving for volume? It's going to be centimeters because we were solving for the height. So about 1.9 centimeters. So with a calculator, this is an inconsequential calculation, meaning like it's not a big deal. Doing that by hand, oh, big deal, right? We divide both sides by 16 pi. That's going to take some work by hand. The calculator, it's no big deal. Yes.
So basically what you're doing is you're taking away everything but H, and then it'll leave you with whatever that number is equals H, and that's what H.
You're doing basic algebra. Danny? There's two versions of this. We're not to the second version. Yes.
Didn't you just take pi r squared and divide the volume?
Say that one more time.
So you take the first part without the h and just divide that with 96. 96 divided by that.
You mean divide 96 by pi 4 squared?
Yeah.
Absolutely. Absolutely. But remember, how are you going to do it without a calculator? So I'm doing both things at once. I'm showing you, well, what would you do without a calculator? Square 4, divide both sides by 16, divide both sides by pi. But with a calculator, well, yeah, let's just divide both sides by pi 4 squared. Absolutely. All right. Did everybody understand what his question was there?
Yeah.
Okay. With a calculator, you do lots of things and very easily. All right. What if this is the problem?
So then you just half the diameter, and then you got your.
So if they give you the diameter, well, then what's the radius?
4.
Oh, by the way, this is the same problem, except I gave you the diameter instead of the radius. Remember, the previous one, it said the radius was 4.
You just have to pay attention.
Agreed. We're not going to do this one, but I'm saying this is the same problem as the previous one. Okay? So let's do another one. All right. Here's where you got to pay attention. This was Danny's question all along. What's our given here?
Base volume.
A capital letter B. Where have we seen that before?
Base volume.
It's the base area. Remember, the formula for any cylinder or any prism is technically what? Base area times height. We haven't used this formula. This is the first time, so pay attention. The actual formula for all cylinders and prisms is capital BH. Volume is equal to BH. Look, it tells me the volume. It tells me the base, the capital letter B. This one, these are the easy ones. Notice there's no pi here. It's just B times H. So I throw in what we got. See what I got? Well, then what the heck do I got to do here?
Divide 12.
Well, that's pretty simple.
And then you got your answer.
And which is, in this case,
Let me grab my calculator.
wait. 36 divided by 12, you need a calculator?
12 divided by 36.
Right? Which is? Seriously, Connor?
My calculator wasn't ready. Oh, God.
Yes, that's why we were all yelling out the answer and you weren't paying attention. No, it's not. No.
No, you calculated it wrong, John.
It's just 3. We would have to put units, so 3 centimeters. Okay? No, it's not.
John, you typed it in wrong, probably.
No, I didn't.
All right, let's do one. We got to do at least one of these. Everybody stay with me. Box 7. Box 7. Here we go. It says calculate H. So we're calculating the height. It tells me the volume, 500 pi. That looks weird, but that's the volume. It says the radius. Notice this would have been someone calculated the volume in terms of pi. It says the radius is 10, calculate H. Step number 1, write down the base formula. So write down the base formula. V is equal to pi r squared. Notice we don't need to do the BH because it doesn't give us B. Okay? So volume is equal to pi r squared H.
Plug in the numbers.
Plug in the numbers. What do we know?
That the radius is 10 and the volume is 500.
Okay, so we plug in those numbers.
And then now we get rid of it.
10 squared is?
10 times 100.
You want to do this in 1 step or 2 steps?
2 steps.
What numbers are attached to H?
100 and pi.
How are they attached?
Division.
How do we get rid of multiplication? So if we want to do it in 1 step, we're going to divide both sides by
100.
1 step. We want to divide by 100 pi. In 1 step, we can do this. Divide both sides. If you want to do it in 2 steps, divide by 100 and then divide by pi. So how about we do it in 1 step? Divide both sides by 100 pi. It's 100 pi is attached by multiplication. What's 100 divided by 100? 1. Cancels. Pi divided by pi? that whole thing cancels. On this side, what cancels?
Hi.
So what's 500 divided by 100?
5.
So therefore, the answer is 5 centimeters.
Oh, that's interesting.
Did anyone get lost in what I just did there? Danny, where'd you get lost? I have the volume and the radius. I plugged those numbers in. There they are. What's 10 squared? How is 100 and pi attached to h? You're getting rid of multiplication by division, so let's divide by 100 pi. Hundreds cancel, the pi's cancel, the pi's cancel. It's really just 500 divided by 100, which is 5.
Wow, that's
I forgot my slash. There it is. Soraya, you had a question? Okay. So that's when we're calculating for H. We also need to do one of those ones where we're calculating for B. You okay? All right, let's do one where we're calculating for B. This is box 8. If you see that B, we're not going to use pi r squared H. We're going to use BH. Yeah, Caitlin.
Our box 8 says height.
So does mine. But it says calculate for B. Okay. All right, plug in what we got. It says B is 64, the height is 8. We're solving for B. Yeah, it literally is this easy. So what do we do to both sides?
Divided by 8, 8 canceled, and 64 divided by 8.
Did you need a calculator for that?
No.
Okay, thank you.
Why would I need a calculator for that?
Well, sometimes you will, but not on this one.
Well, you're making numbers funny. So
By the way, base area, I made a mistake here. Base area is an area, so it should be centimeters squared. I'm not sure why I haven't caught that mistake yet. That should be centimeters squared. If you're solving for B, the answer is going to be in square units because it was the area.
It doesn't really matter what you're solving for because most of the time you're just doing the exact same thing. You're just canceling them out until you.
You are, and like I said, for this particular form, everything looks to be multiplication, so you're always going to be dividing to solve. All right. Last one. There's my square. I got it right that time.
Doing a triangle.
Okay.
If there's no units for calculating height, we just put 20.
You just put units, right? All right. Hey, you two, stop.
Wait, we still
Not if we're solving for height. That would just be units.
we're already in the base.
If we're solving for volume, yeah, it'd be cubed. If you're solving for B, just the word units, and you're done. Okay. So there's a B there, so we're going to use the BH formula. Plug in what we got. 24 pi. 2 is your.
Well, just 2 is your.
So what are we going to do?
We're gonna divide by 2, and then it's gonna be 12.
12 pi.
12 pi equals h.
Okay. Now, did it say leave it in? It didn't really say. It's kind of up to us. If we did multiply by pi, we would get that answer. Okay. It actually didn't tell us whether to leave it in terms of pi or
This is
not.
more accurate. Pi or 3.14.
Pi, but it's still an approximation.
Well, I mean,
It's more accurate. Danny, you had a question?
Did you say there was a competition about who could memorize the most digits of pi? Yep.
So you can become a millionaire. Like there's no joke. You can become a millionaire if you can determine the most digits of pi that exist. There are companies that will pay you millions, not hundreds, millions of dollars if you can find pi to more digits than anyone else came up with.
I think somebody's done like 1,000.
Oh God, it's way more than that.
More than that.
We're not talking about saying, we're saying you come up with the number. They use these numbers for like when you go online and you pay money. Well, how do you keep people from stealing the money?
You don't.
Well, clearly you do, otherwise no one would use the system. I mean, why are we okay with paying money online,
Cybersecurity.
right? And how do they accomplish that?
With a very unknown password.
So we have these things called cryptology. And cryptology is the science of encrypting things. In other words, hiding this information away from other prying eyes. And one way of doing that is encoding things. And it turns out that having a number that's very large that can be calculated or known is an important thing, and that's why calculating pi to a very large number of digits. I mean, we're talking about millions and millions.
Make up the digits of pi, or do
You
actually
can't. You have
find
to
out?
come up with those. And so what people have done is they've written computer programs and they've turned the computer on for long periods of time,
Wait,
and
so
they've
you
come
can't
up
just-
with. Let me finish the sentence. And they've come up with long versions of pi, and they've sold that to companies that use that number to make better encryption systems.
So you can't just say this number is now another digit of pi. You have to actually calculate the digits of
That's
pi.
right. Yes.
Since pi is infinite, that means it is possible that there is a part of the code that says 8675309.
Not only is it possible, that's repeated a couple times. However, in totality, right, there's a 3.14 many times inside of pi. But in totality, there is no pattern. So for instance, you might find the numbers, in fact, it's the first four numbers, 3.14, or those 1415. So these four numbers, 3.141, will be found in pi. The only difference is that the next digit won't be the same as the previous one. It'll change up. And so there's no pattern, no recognizable pattern.
Well, then how do you calculate the digits of pi?
You take a circle, calculate its circumference, and divide it by its diameter. That's the definition of pi. Any circle divided by its circumference divided by its diameter.
And that number will keep going.
And it will never stop and never repeat.
And so you just have a computer doing that for what, 3 years, and then boom, you got millions?
You got it.
Dang.
All right.
Yo, I'm gonna want to do that someday.
All right. Let me finish up the class here. Oh, that is the finish. There we go. Okay, hold on a second. 1 second. All right, there's number 8. So we're given the volume. The volume is 64. We're given the height. The height is 8. Well, there's only one number attached to B. I said there was one mistake here. I didn't put my units correct. My units should be centimeters squared.
Wait, but why isn't everybody just doing that then? Why don't they just have a computer that you can go on for a couple
That is a good question. Have you ever heard of cryptocurrency mining?
I think so. I don't know how it
Pete? They have these supercomputers that do this process that uses a whole lot of electricity, and they mine bitcoins. I don't know the details on it. Sorry, man. All right, Eleanor, any questions?
No.
All right, cool. We'll catch you tomorrow.
Okay, bye.
See ya.